Welcome back to our live training session here with our Honda EP3 Civic. This training module, we're going to now take a look at doing the full throttle tuning and calibrating process. We're going to be focusing on how to dial in our fueling, our variable cam control, and our spark control with a focus on setting up our knock control so it's functional and it's going to guide us in making our spark timing adjustments, whether we're on a chassis dyno or not. We're also going to be talking about how to dial the variable cam control in without a chassis dyno, so what you can look for in your log data to determine if a variable cam control change was actually making a torque gain or loss. It's going to be pretty clear as to spotting the trends and looking at your data to be able to determine what is going on within your calibrating and tuning routine. Now this engine, Honda K24 engine, is equipped with VTEC. We're not going to take a look at dialing in the VTEC in this training module. We'll be splitting that into the next training module, looking at the high cam tuning process as a separate process. VTEC equipped engines essentially have two cam profiles and act like they're essentially two different engines, so to speak. And we're going to learn how to calibrate low cam, high cam independently, and then actually setting the VTEC point in that next training module. Let's talk about a few things that we need to know heading into this training tutorial and what we want to have prepped in our file. Then we're going to jump in, start to do some demonstration here on the dyno and go through the tuning process in kind of a rapid fire orientation and get everything sorted out. So first things first, if we take a look, I am on my estimate tuning page. In our previous training module, we dialed everything in here from essentially 10 to 50% throttle. Now we're going to be taking a look at dialing in our very high throttle angles here, 80, 90, 100% throttle, and getting all this sorted out in full throttle conditions. Now what we can actually do is interpolate then between, let's say, 50 to 90% and fill in the blanks in the table here. Now we actually want to drive it and test it, but that'll give us a quick way we can get very close to what is going to be ideal values in our estimate table to be able to then go back in and check them. So this training module, we're really going to again focus on just these last few columns in the table to get all this sorted out. Now these are all at 100%, which is not going to be accurate, and we're likely to be too rich or possibly too lean in certain areas here. So we're going to look at setting this all up, looking at working with our closed loop correction to make our adjustments and get everything in line within our estimate table. The other thing we have going on, variable cam control. Let's jump into our intake cam VVT. That's what we have in our engine, intake cam only control on a Honda K24 engine. Looking at this table is set up on inlet manifold pressure versus engine speed. Now we have the table all set to essentially values of 30 degree as we go up here into high RPM. That's not going to be ideal. And in fact, what I want to do to get started with this and doing the calibration process, I'm going to go here from something like 70 kPa and higher and zero out the entire table. Now we want to go and do that so that we can kind of feel out the variable cam control and get an idea as when we're making our variable cam control updates in the table, what is going to work, what's going to make power or not. We can look at our fueling data. We also have our mainline dyno that we're going to be doing our pulls on here to actually see the effect by changing the variable cam control. So whether you're on a chassis dyno or you're doing this on the road, you'll get a good feel for dialing in these values, and we'll talk about that process. But we want to have a baseline. So I'm going to baseline the engine here at 0 degrees. So I'm zeroing out the table values to get things going. The next thing we have going on here in our ignition tuning table, the ignition tuning and our ignition timing is going to be set in a pretty conservative manner. Now in part throttle, so 50% throttle and below, engine load normalizes our axes, which is relative to throttle angle. That's how we configured it. We're going to have our values dialed in here. But above this range, we're going to find that we have our values when we're at 80, 90, 100% throttle set to approximately 14 degrees timing. Now this is a low spark timing amount. I'm probably going to be anywhere between 20 to 25, 26 degrees timing maximum. This is a high compression engine. It's about 12.5 to 1 compression. Factory stock compression's anywhere between 10.5 to 11 to 1, depending what market K24 engine you're talking about, you're dealing with calibrating and tuning. But this is going to allow us, by having low spark timing, to focus on our airflow model tuning and our fuel model tuning, getting that sorted out, dialing in our variable cam control, working out airflow, fuel tuning 100%. Then we can jump into spark timing and start to tackle this. The other benefit by running low spark timing here is we know the engine won't knock, which allows us to go in and dial in our knock control, getting the knock threshold set up and configure it properly so that when we do have a knock event, we can actually detect it and utilize that for spark timing, calibrating and tuning. So either we don't have a chassis dyno or a chassis dyno, doesn't matter. The knock control can tell us if we're actually getting knock, if we set everything up correctly, and then being able to dial things in based around whether it's knocking or not, and we'll sort this out fairly quickly. So we're going to do something very specific with this. we're actually gonna go into the table here at 1500 to, let's say, 2500. Now I'm gonna go into the table values here and set them pretty high, something that I know the engine's probably going to knock within. I'll double these values, or even add something like 10 more degrees of spark advance here. That's gonna definitely induce knock. I wanna do this at a low engine speed and a high load via throttle angle, because this is gonna put the engine into a knock condition. So low engine speeds, high load, high throttle angle, the engine's way more likely to knock if the spark advance is too high. We want to put the engine into a situation where it's going to temporarily knock so we can evaluate the knock control and getting everything set up. So we need to go and set up the knock frequency so it's tracking correctly for our engine. It's actually having a good knock to noise signal ratio. We'll discuss that here in just a minute. And then also making sure that when it actually knocks, we know that it is a knock event and not picking up just noise. This engine's pretty noisy with the stock knock sensor, so I want to be able to filter all that out. So we need to make sure we're able to do the knock calibration for the frequency correctly, so the whole knock control routine is going to work, and we need to do that by inducing knock. So we're going to go and focus in this area right here. I'm going to set my values as something like 22 to 24 degrees of timing. Now I know that is too much timing in that area, and the engine will knock, and that's the point. We want to do this in a controlled manner. I'll demonstrate how to do this here in a little bit. So we've set our values in here. Now let's go into our knock tuning page and talk about a few things. We need to calibrate our knock threshold table, but we can't do that until we figured out what the proper knock frequency is going to be. Now we have our mode here. We can see that the enable option, enable A, B, ABC, A, B, C, D. We have a couple different choices. We're gonna be choosing enable A, B, C, and D. What this is going to do is allow us to run through these various frequencies, and we can actually monitor how the knock control is going to react to see our knock output to noise ratio. What we're looking for is that we have a pronounced knock output with the least amount of background noise. So this improves how the knock control is going to work and the repeatability of the knock control. Now, if we look at the values here, 10,000, 12,000, 14, and 16,000 hertz, this value that Motec populates kind of as defaults to start off with here, this is assuming you're running a second order knock frequency. A first order knock frequency is based on the bore size of the engine. We can actually calculate that. We're going to use our Excel spreadsheet calculator here in just a minute to be able to figure that out. What we want to do is double our knock frequency, and we want to be on the second order frequency typically. The second order frequency is going to give us a better knock to noise ratio and more repeatable and consistent results with our knock control. Let's actually take a look at how to calculate this. If we jump here into the Excel spreadsheet and we go into our knock page right here, we're going to find that we can enter in the engine bore size and figure out both the first and second order frequency that we want to put into the Motec for testing purposes and to get things started. So in my case, I have an 87.5 mil bore. I've already entered that in here, and we can see my first order frequency here and my second order frequency. Let's enter those for channels A and channels B. So we're going to go ahead and do that. And then we have channels C and D that we can also test within this routine. So I'm going to go in here. Let's jump into the window, and the frequency A here, I'll set it to 6,500. Frequency B, I'll do it to 1,300 or 13,000. I'm sorry, hertz. And then I'll leave a C here at 14,000 and a D at 12,000. I'm going to go ahead and try to focus tighter into that second order frequency. Most times, first order is going to produce just way too much noise along with the knock sensor output, meaning the amplitude is so high, it'll easily eclipse the limit of the table here at 100%, even when we have no knock. Our goal is to get the knock to noise ratio so it's reasonable, so that when we don't have knock, we're going to find that it might be outputting something like maybe 5, 10, 20% at most. And then when we do have a knock event and it has a big spike in the knock output at that knock event, it'll be able to run within the range that this table can be calibrated in, 0 to 100. This will make more sense as we start to go through this and unfold this process of how to dial this in.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.